Good morning and welcome to Mr. Mac's class. I'm Mr. Mac, John Macalutis, actually doing this assignment for National, recording a lesson plan about circumference and the special relationship that it has with diameter and how they came up with pi. We actually did this lesson or a takeoff of it a couple weeks ago, and our here at school we are actually going through testing right now, so it's been kind of a crazy week. Anyways, I'm attempting to kind of go over the lesson, what we worked on in the past, and show you some of the technology and some of the ways we adapt to our English learners. I actually have one student that didn't speak English when she came here. She came at the semester, and we got her Spanish version of our textbook and our science book too. I actually have 6 preps here, so I teach 6th grade English or 6th grade science, 7th grade science, 8th grade science, and then I have the kids again for 6th grade math, 7th grade math, and 8th grade math. So we've got quite a few things going on. At any rate, this is my website, and one of the cool things we have and features here is the kids can go to their particular class, especially in math, they can get homework help. This is my J-Touch screen. The kids get on here, they know how to use it, they can plug their Chromebooks, which we have a Chromebook cart, and we have 30 for the room, and they're able to go ahead and get on and access the internet either while class is going on, or sometimes I'll have them working in groups. We also have a software called IXL where they can do math problems and I can track them online as well as rove the room and help them with individual problems. So helps out a lot with the diversity, dealing with kids that are a little below average and the kids that are above average. I can kind of send them on different paths and then give them individualized help, which is really nice. At any rate, some of the things we use is the J-Touch is a nice feature. I can use my overhead projector and work from the desk while the kids are looking up here. They like using the touchscreen interface. I can highlight things. There's a drawing board. It's kind of like a dry erase board. Sometimes I'll have the dry erase board. I have one in the back of the room and this other one on the side, and we get problems going on the board and get the kids getting real active. But at any rate, I've designed this website where they're able to go and get homework help. It'll kick them straight to, we're using CPM, and they can go to whatever lesson we happen to be on. This is actually, like for chapter 1, this is just an example. They can go and get individual lesson on the homework, and it'll walk them through and give them hints on particular problems. And it'll show them as they go what to do. The touchscreen gets a little funny. Never seems to want to work when you want it to, but it tells you what to do step by step and gives you hints along the way. So it's a nice feature for parents at home. They can help their kids with their homework, and the kids can get helpful hints at home as well. Or if they get stuck in class, they can use a Chromebook and get on the website. So the definition of a circle is a point that has a center. If we went out a distance, say 6, 1, 2, 3, 4, 5, 6 roughly here. All right. There's another point that's 6 away from there, and here every point that's 6 away from the center would form a circle. And you can take and make a compass. Kids will be working with compasses. We're going to use the dry erase board to do that, as well as use the compasses we have in our little tubs that have compasses in them, but sometimes it's more fun to do it on the board. And that's a circle. So every point that's a distance from the center, in this case it's 6, that distance we're going to define as radius. So if it was in inches, the radius would be equal to 6 inches. So there's a point all along the way that's 6 inches from the center, and if we went and counted them all, they form a circle. If we take a point that's on one side of the circle and we go across to the other side of the circle and go through the center, that distance there is called our diameter. So the kids have these toolkits, and in the toolkits I have them, there's the circle vocabulary, they can look it up, and then they can, as we go through this lecture, we'll have our math notes, and there's more room here to go ahead and draw the circle like I'm showing them, and to label things so they have a place to reference it. So far we've defined D as diameter. And the diameter is 2 times the radius, and that goes from one point of a circle, or any point on a circle, through the center to another point. And the circumference, which we'll label C for circumference, is the distance from a starting point and going your way all the way around a circle. That distance, and since it's a distance, it's going to be in units. We've also discussed area of different shapes, and that's where we're at right now, is we were discussing area and how to find it as well. But those units would be squared, and circumference, the units are just in inches, so it's because it's a distance. And from there, what we're doing with the video is discovering what pi is.
Circumference and his son, Radius, sat in the shade of a tree, enjoying a delicious midday meal. Partway through the lunch, Circumference grabbed his stomach and doubled over in pain. "Oh, my belly," he wailed. "It feels like fire. Radius, run to the castle, find the good doctor, and get me a cure." So from this text, I just want to highlight the words circumference, which is the measure of the distance from the outside of a circle, or the perimeter of a circle, and radius, which is the measure from the center of a circle to the outside edge of a circle. So to put this another way, circumference is the boundary of a circle.
So one of the nice things about using the technology and the media of I can stop things whenever I want. I can give the kids a chance to catch up on taking their notes, because videos sometimes go a little bit faster. I can add on to whatever is being said. I can answer any questions, and I can make sure that everybody understands the vocabulary that's being used. Radius is one of the new words we're using, so I want to make sure they understand what that is, circumference, and then make sure they write it down in their notes so they get a good feel for the vocabulary. Also, if there's anything else people don't understand, I can answer those questions at this point.
Now the knights are surrounding them with swords drawn. "Radius, Lady Di, we've come to save you," they shouted. It was now or a dragon forever. Radius gave the creature 3 1/7 spoonfuls. Kaboom faroom! A big explosion shook the forest. When the smoke cleared, a hardy human Circumference stood in their midst. Circumference leaned over and hugged his son. "Thank you, Radius, but how did you do it?" Radius explained about the pi and the measurements. Circumference and the knights listened with amazement. Cheering, they swept Radius up on their shoulders and returned to the castle. "Pies! Let's eat some pies!" shouted Circumference. "Radius saved my life."
Okay, so at this point, I'm going to go ahead and we'll finish the video, and I'm going to describe how we're going to take the different circles that we've brought in. Here I've got 2 examples, and we're going to measure some of them using English units. In this case, we're going to use inches. We could just as easily go outside, and if we find some circles on the playground, and we could have them go out and measure in feet as well. So this particular shape, this frisbee here, was 9 1/2 inches. So what I'm going to have them do is, on their worksheet or in their toolkit, they're going to figure out or discover pi for themselves. So we've defined circumference and diameter, so they know what that means. The 9 1/2 I just measured is the diameter. It was the distance all the way across through the center, so 9.5 inches. And then the circumference we can measure. We talk about precision and ways we can measure around the outside or the border, and it's not going to work very well to break a ruler, and the tape measure doesn't work very well. So I asked them about different ways they think they could do this, and one of the ways is we're going to provide this string. So if they work in pairs and they work their way around the edge, all right, which might be tough to do on your own, you can take this string and then stretch her out and then measure that. Okay. So they'll get a measurement here. That measurement comes to about 30 inches. And then from there, I want them to get a ratio and figure out how they're related. So if the circumference is divided by the diameter, we get 30 divided by 9.5. And I have them use their calculators. 30, that comes to roughly 3.16. So that's one shape. I'll have them do a second shape. We'll do different units. This one here has a diameter of 7.1 centimeters. So this diameter is equal to 7.1 centimeters. And the circumference we can measure by using string to go around the edge. And that one comes to about 23. So if we take circumference over diameter here, we get 23 divided by 7.1, and that equals 3.24. So they're going to go through and they're going to measure several circles and they're going to see if they can get a ratio that's always the same. And one of the things they're going to find out is that they're not perfect. And we actually did a unit a few weeks back where we measured using a tape measure, and we tried to measure. Everybody took the same measurements with the width of the room with the tape measure, and then we also did it with just a ruler. And then we took that data and we found that none of it was exactly the same. And we asked ourselves why and which one was more precise, or we defined the word precision. So one of the reasons why we're not getting exactly 3.14, all right, I'll bring it up again and touch base on what we learned in previous lessons about precision and how errors can take place. And they're pretty good about saying that there could be human error, or maybe the device wasn't perfect. Like for example, some of the rulers had ends broken off, or this has actually extra. It's there's a little bit more than 12 inches. So in some cases the kids assumed it was 12 inches. And then the more times you measure with a small device, they found that the error was off by more. Where with the tape measure, since it was continuous, it was a little bit more accurate. But even still, when kids measured with the tape measure, they got different measurements. Anyway, I turn the kids loose. They go do some measurements, and then when we get back, before the bell rings, I kind of bring things full circle. I reminded them about their toolkits and the words that they learned about the center of a circle, and that a radius is the distance away from the center. That's the distance all the way around, and that border is called the circumference, and that the diameter is exactly 2 times the radius, or the distance from one point on a circle through the center and all the way across to the other side. And then we worked on seeing if we can define what pi is, and then how we can apply it. If we knew pi and we knew the diameter, we could find the circumference. Or if we knew the circumference and we knew pi, we could find the diameter. So if we have 2 things we know, out of the 3 things, the one thing we don't know, the unknown, we can always find. And so we'll work through some problems here in our homework. And I'll be circling the room, answering questions, working with the kids individually. Hopefully you like the lesson, and I know the kids enjoyed it. They were a little squirrely right now because we're testing, so if there's any other examples where I'm working with the kids, it could be because we're adding area into the picture as well as volume. So hope you enjoyed. We'll catch you next time. Thanks for visiting. Yesterday we talked about surface area.
I'm not good at that.
Okay, so remember, we're gonna use surface area for this shape here, which is actually the end of a bat billet. Okay, it comes in a long cylinder,
Yeah.
and then we turn a bat out of it. So this is the end of one that was cut off. Okay, remember the surface area, if you think about skipping a rock across the water, you're touching the top. So all the things you can touch are considered the surface. Okay? But the stuff inside, if I could fill it up with liquid, the stuff inside is what?
The liquid.
No, not the liquid, but the space inside is called the volume. Okay? So, remember big B, little b?
No.
Yesterday when we did triangle, area of a triangle, 1/2 base times height, that little b was the base on the bottom of a triangle. What's the big B?
I don't know.
The base of the shape. So if this shape was touching a surface, like there,
That was loud.
the part that's touching either this flat surface or a table, all right, is called the big base.
The big.
So when you go to calculate the volume, you'll find the big base, and you'll multiply by what? Think of this base in layers, and if we built up enough layers, you'd have the whole thing, right?
The amount of layers.
So what is this distance right here?
The
base times.
Octavia, what's that distance? Height. Right. So if we can calculate the area of the base, what's the shape of this object? It's a circle. So if we can calculate the area of a circle and then multiply by the height, what will we get?
Our answer.
Everything inside, which is the volume.
Forget what I just.
Now, how would we find the surface area, do you think, Michelle? The surface area. What surfaces can I touch on this shape?
Bottom on the side.
What shapes do you see? Okay. How many of them are there?
2.
Well, there's one on each side, right? If it was the base on the bottom, then you'd have the top as well. So that would count the 2 circles. We could calculate that if we can measure the radius or the diameter and take half. What other parts do you see?
The cylinder.
And if this was a stamp and I rolled it out, what shape would it be?
A line.
Well, it's not a line. Exactly. It's a rectangle.
What? How?
So do you know how to find that rectangle?
No. It was like this.
How do you think you would do it?
I mean, if you like
What do you
the sides and
What do you think What do you think the distance is right here? Watch my finger.
the
circumference.
Ah, the circumference. Now, is it just the circumference? Is it just a line, or is there more to it?
The circumference.
So what would you multiply that circumference by to find?
The height.
Right. Can you measure that?
Yeah.
Yeah. So to find the surface area, you're going to find the area of the circle. You'll multiply it by 2. Why?
Because there's 2.
Because there's 2 sides. And then to find the surface area of this edge, you're going to calculate what first?
Circumference.
Circumference. And then you'll multiply by what?
The 2 sides. The height.
The height. If it's a height, if you look at it this way.
said that.
And that would be everything you can touch. Okay? You guys got that? So this is kind of your challenge one today. I want you to do this one in centimeters. So you're going to go inner diameter or outer diameter?
I don't know. Inner?
Yeah, just be consistent. So you're going to, when you do your circumference, are you going to do the outer diameter?
Yeah.
So then when you do your outer, then you got to be consistent and make sure your diameter is going to be the outer diameter. You know what I mean by that? Because you could measure from here.
Alright.
2, right? And then you want go to the inside, and that would be the inner diameter. If you want outer diameter, you go to the outside edge, and then go to there. So just do it the same, okay? And then, you know, with the circle, you want to indicate that on your paper.
Probably, yeah.
We're not doing the top of the bottom.
That's too bad.
What do you mean? Oh, you're going to do both.
I'm tired.
You're tired? It's Wednesday.
Yeah, but I went to Yuba all day yesterday.
You did what all day?
I went to Yuba. Start at 1.
How come you say Yuba, not Yuba City?
Because I want to go to Yuba City.
What'd you go there for?
My dentist appointment. I'm getting my braces
So your teeth hurt today?
off. No, I'm getting my braces off on May 17th.
Oh, you didn't get tightened up then? You're going to be no braces anymore?
Put that pink thing so they could. Kenzie!
Whatever. I have no.
All right, here's for your circumference.
No, but like right there.
Okay, so on a circle, you be careful because
It's 8.
are you going inner diameter or outer diameter?
What do you mean?
Meaning, if you measure from the outside edges,
Yeah, that's why we're going to that.
and then when you go to do your circumference, you got to do the same circle. Because really, if you think about it, there's two circles. There's the outside circle, and then there's the inside circle. So we want to make sure that you're using the right diameter.
See, you made us lose our spot.
I'm sorry.
Okay.
That's not
So we
funny.
have to do the inner diameter and the outer diameter.
No, you just need to be consistent. So if you use the diameter that's on the inside, when you go to do your circumference, you need to use the inside of the circle.
So which one do you want to use? Inside or outside?
I don't care.
What's easier?
Really?